Hello, and welcome to this session on Making Estimates with me, Mr. McIver, here at the London Central and North West Maths Hub. Estimating is very much an everyday skill. People use it in their work every day. Estimate the cost of refurbishing a room. Experts at the health service will be estimating the rate at which a disease might spread, and at a more mundane level, you might want to estimate how long it will take to drive from your house to your campsite in northern France. So what kind of estimates are we going to be looking at today? What's the weight of an average family car? How big is a cup of coffee? How far do you live from school? What's the height of this classroom? Although these are more straightforward than the ones we looked at the start, the way you go about making this kind of estimate is just the same as the way professionals in the fields we've just spoken about go about their jobs. So let's look at these one by one. What's the weight of an average family car? I googled it, and I found this very helpful hit here at an Indian website. The average family car is between 800 and 1300 kilograms, about a ton. What about a standard coffee mug? According to Wikipedia, a standard coffee mug is between 230 and 350 millilitres of liquid. Well, that's pretty straightforward. We can answer those by looking them up online. The other two questions are subtly different. What's the height of this classroom is not something you can find on the internet, unless you happen to have somebody who blogs about your classroom online. So how do you go about making those very particular estimates that are specific to you? First of all, we'll look at the height of the classroom. Here's a picture of a typical classroom. In order to make a sensible estimate of its height, you need to know something about the heights of everyday objects. And one of the figures it's helpful to bear in mind is a standard door is about 2 meters high. So if that door is 2 meters high, all I need to do is figure out how many doors it would take to get from the top of it to the ceiling. I think that looks like about half a door. I'm estimating 1 meter. So this classroom is approximately 3 meters high. What about the second question? How far do you live from school? There are a number of ways you could get this pretty accurately. You could borrow a trundle wheel and pace it out. You could look at the distance on a map, draw a line on the map it out. What does that look like? 200, 400, 600, 800, just over a kilometre, maybe 1.2 kilometres? Or you could use a related fact. For instance, average walking speed's about 5 kilometres an hour, which means you'll probably do a kilometre every 12 minutes, maybe 10 if you're walking quickly. So if we look back at the kind of estimates that teacher was asking in the classroom, they fell into two broad categories. The kind of general knowledge ones, what's the weight of a car, how big's a cup of coffee, and the general knowledge plus a calculation ones. What we're looking at today is essentially the ones on the right, where you have to combine some general knowledge with some calculations, but you do need to know some basic facts to make much headway on estimating. So now let's look at a couple of more complex examples where you have to apply some knowledge and calculation skills. How many cups can I get from this water cooler? There's obviously going to be some calculating involved. So the first question I ask is, what is the calculation I need to do? Alongside that question, I need to ask, what do I actually know that might help me to get to the answer? So there are two types of questions that you need to ask yourself when faced with an estimation problem. What's the calculation is fairly straightforward. It's just the size of the reservoir divided by the size of a cup. And what do I know? Well, we've just found out that a standard coffee mug is 250 to 350 mils. And if you remembered what the Wikipedia page said, it said that's about twice a standard cup. So there's a cup. I suppose that means it's between 115 and 175 millilitres. Now, in the previous sessions, we've been looking at bounds, upper and lower limits, and finding out whether the figure we've got is reasonable. Now we're actually doing calculations. We don't want to do them all twice. We're just going to pick one reasonable figure for each estimate. I've got the size of a cup at between 115 and 175 mils. I'm just going to pick a figure in between the two that's going to be easy to work with. I'm going to go for 150 millilitres. That is my estimated cup size. Okay, how big is a reservoir? One of those big bottles you get on the top of a water cooler. Short answer, I don't know. However, I do know from going shopping that a really big bottle of soft drink holds 2 litres. And I can compare it to the size of the thing I've got. Looking at those two objects side by side, I reckon the big one is between 5 and 10 times the size of the small one. So that means 10 to 20 litres. But as before, I'm going to pick a single figure. And I'm going to pick the one halfway between 10 and 20. I'm going to pick 15 litres as the size of my water reservoir. Now the calculation is really easy. 15 litres over 150 mils. Before doing the calculation, make sure you get everything in the same units. And you end up with a figure of 100 cups before you need to replace the big water bottle on top of the cooler. That was quite a straightforward estimation problem because there was really only one calculation you had to do. Quite often, in the types of problems we were looking at right back at the start that people do for a living, there are multiple stages in estimation processes. So we're going to look at a slightly more complex problem now. And I'm going to go for rubbish. We all produce it. We all chuck it in the dustbin. And much of it goes into what we call landfill. Landfill means you dig a big hole in the ground, chuck all the rubbish in, and cover it over. Here's a medium-sized city in the north of England, City of York, population 200,000. I'm a city planner and I have to decide how big a hole I need to dig to take all the rubbish the city will produce for the next 20 years. As before, the first 2 questions I ask are, what's the calculation and what do I actually know? Well, there's one fact staring me in the face right there. I know the population's 200,000. I need a big enough hole for 20 years, so I suppose if I knew the volume of rubbish I had in 1 year, I'd just multiply it by 20. But I don't. I have no idea how much rubbish the City of York produces in a year. Let's try to break it down a little into more manageable chunks and see if something comes into view that we can get a bit more of a handle on. What about rubbish per week? 52 weeks in a year, so if I knew how much rubbish the City of York produced in a week, I'd just multiply it by 52 and then 20 and, well, I still don't know how much rubbish a city produces. I'm more used to what individual people do. So, I suppose I could break it down to this. How much rubbish does each person produce each week? Multiply it by the population, multiply it by the number of weeks in a year, and multiply that by 20. Well, I live in a city, and I know something about rubbish. I put my rubbish in a dustbin. I also know roughly how big a dustbin is. I'm not going to estimate the dimensions of a dustbin. I reckon my dustbin's about 1 metre high and about 50 centimetres wide. I am now going to model that dustbin as a cylinder, which is that size. So there is my imaginary, idealised dustbin. I can now work out the volume of my dustbin. I suspect that's a bit on the big side, but let's err on the side of caution. We want to make sure that this landfill site lasts the full 20 years. Now, I suppose, I need to think, how many dustbins do I fill a week? Well, one person probably doesn't fill a whole dustbin a week. Let's say half. The average person fills half a dustbin a week. Remember, once you've got the calculation and the mathematical model built up, you can always go back and try to get better data to put into the calculation. The hard thought goes into constructing this series of ideas in the first place. We now have each individual filling half a dustbin a week, so the calculation we need to do is this one. Half of the volume of a dustbin times the number of people in York times the number of weeks in a year times the number of years the landfill site has to last. That is a pretty big number, 20,800,000 metres cubed. How big a hole in the ground is that? Well, what do we know about holes in the ground? I'm thinking about a model here, so I'm going to use a rectangular hole, a cuboid, because it makes the maths easier. Picturing the sort of diggers and machines I've seen around the place, I think I'm going to be hard-pressed to dig a hole more than about 10 metres deep. Even that is a pretty big hole in the ground, but let's say we go down 10 metres. And let's say we set an arbitrary width of 100 metres. How long does it need to be? Now I have to do a little bit of algebra. You see how I've introduced a letter there to represent a length? It's not very hard algebra. The volume of a cuboid is just length times width times height, so I can write that down. L times 10 times 100 is 20,800,000. I work it out and come to the conclusion that my hole in the ground will have to be 20 kilometres long. It will grow in length by 1 kilometre each year. How big a hole we need? One that's that big. To be honest, that's a pretty weirdly shaped hole. I probably wouldn't buy a plot of land 100 metres wide and 20 kilometres long. I'd probably try to square it off a bit if I was that city planner. If we stick with the 10 metres depth, we simply have to get a surface area of 100 times 20,000, 2 million square metres. Well, I could get 2 million square metres by doing that. Having it 1 kilometre by 2 kilometres, that's 1,000 metres by 2,000 metres. That's a slightly more reasonable shape. So I would now have to go back to my boss and say, we need to buy a plot of land 1 kilometre wide, 2 kilometres long, and dig it out to a depth of 10 metres for our landfill site. If I was a city planner, I'd work pretty hard at persuading the residents of York to start chucking out a bit less stuff. Let's review how we went through this. The first thing we did was model the real-life situation through calculations and often little sketches and drawings where they help. We had to ask ourselves 2 critical questions as we did this. What's the calculation I need to do? And what's the information I know or need to estimate in order to carry out this calculation? It's then a kind of back and forward mechanism of looking at the calculation and then making an estimate and then putting it back into the calculation and then going back and seeing if we need some more information that gradually builds you towards a final answer or solution to the original problem. But all you've got at the end of all this is a numerical solution. You need to apply it back to the original problem and say, does this really make sense? This looks like an awfully large bit of land to devote to rubbish. I think I'd want to go back and find out if people really do chuck this much stuff out. To make all of these estimates, I've had to use a certain number of useful facts. First of all, length. 1 centimetre is about the width of your little finger. As we've already said, 2 metres is the height of a door, and you might find it useful to remember that 100 metres is the length of a football pitch, but only if you're interested in football. If you're not, it might be useful to think of some other object or place which is about 100 metres in length. And finally, a kilometre is about the distance you walk in 10 to 12 minutes. What about volume and capacity? Well, we've already said that about 300 mils is the size of a mug of tea or coffee, and 2 litres is the size of a large bottle of drink. And finally, mass or weight. Now, physicists, I know that mass and weight are not the same thing. But in everyday parlance, the words mass and weight are used interchangeably, however wrong that might be in the strict sense of the word. And it's useful to remember that a small bag of crisps is about 25 grams. 1 gram is a very, very small amount. 20 kilograms is the weight of a heavy suitcase. The limit for hold baggage with most airlines is round about the 25 to 35, 40 range, but in fact once you get much above 20, it's actually quite hard to lift. 80 kilograms, that's an average person, and a ton or 1,000 kilograms is an average sized car. And connecting all these things together is the mass of water. 1,000 litres of water represents 1 cubic metre of volume, and believe it or not, that weighs 1 tonne. If you want to know what 2 kilograms feels like in weight, pick up a large bottle of soft drink. And now a few others relating to human geography in the UK. 10 million is about the population of London. Other large cities like Birmingham, Manchester, Glasgow are more like 1 million. The population of the United Kingdom is 65, 66 million, thereabouts. The population of the world is about 7.6 billion. That's 7,600 million. And finally, the average lifespan of someone in the UK is about 80 years. In fact, it's a little bit more than that. You might find it useful to keep this screen in front of you, as it contains some useful information that will help you answer the questions you have been set.